try to solve it yourself. Well, there's a lot of information inside, so we need to look one by one. Fx and gx is continuous function, and g e to the power of x is equal to fx and g e to the power of x minus 1 plus 5 in the range of this and this, and integral of this is this, and integral of f ln x dx is ae plus b. We need to find a and b. So let's first find the direction of how we should solve this. We have to find a and b, and to do that we have to integral f ln x dx 1 to e, but we have only fx in the information with g to the power of e x. So let's substitute ln x into something else, for example t. Then 1 over x dx is going to be equal to dt, which means dx is going to be x dt, and because ln x is equal to t, x is going to be e to the power of t. So dx is going to be equal to e to the power of t times dt. So this integral will be changed like this. Because we substituted ln x with t, it will be starting from 0 to 1 ft times e to the power of t times dt. So in order to solve this, we should know what ft is and integral this ft times e to the power of t. So what is this? We should try to find this out in some other conditions. As you can see, g e to the power of x, we have the fx. So in order to find ft, we need to find it from g e to the power of x. So let's use the third condition, where gx dx integral 1 to e squared. But as you can see, we have the information of g e to the power of x. So we need to substitute x. Let's substitute x into e to the power of y. So let's put x equals e to the power of y. Then dx is going to be equal to e to the power of y times dy. If so, the range of the integral will be changed into starting from 0 to 2. So it will be expressed g e to the power of y times e to the power of y dy integrated from 0 to 2. Now after that, let's use the second condition. When x is from 0 to 1, it is fx, and when x is 1 to 2, it is going to be g e to the power of x minus 1 plus 5. Let's put that in the integral. Let's divide the integral from 0 to 1 and 1 to 2 and put in the values of g e to the power of y. Then the integrals will be shown like this. And if we divide the integral 1 to 2 with the term having g e to the power of y minus 1 and the term that does not have g involved in it, it will be expressed like this. And this is going to be equal to 6 times e squared plus 4. As you can see, we have found the integral 0 to 1 fy e to the power of y dy. We didn't find the exact function of f, x, y, or something else, but we know this integral is something. So let's put that as a large A. For the second integral, we have y minus 1 in it, so let's substitute that into z. Then dy will be dz, and the range will be from 0 to 1 g e to the power of y times e to the power of g plus 1. G e to the power of g. Because there are a lot of letters x, y, z, t, large A, e, and so on, we need to focus and keep track of what we are doing. So this integral can be changed like this, because e to the power of g plus 1 is equal to e times e to the power of g. It can be expressed like this. And as you can see, this is equal to e times large A. So what we are solving is large A, and we have found that this integral is equal to large A plus e times large A plus integral 1 to 2 y times e to the power of y dy. And this is equal to 6e squared plus 4. So let's integrate the third part. Then it will be expressed like this. Large A plus e times large A plus 5e to the power of y from 1 to 2. So it's going to be bracket e plus 1 bracket times large A plus 5 times e squared minus 5 times e, which is equal to 6 times e squared plus 4. We need to find out the value large A, and e is not variable, it's a constant number, so let's solve it. Bracket e plus 1 bracket times large A equals e squared plus 5e plus 4. This is a quadratic equation, and if we factorize it, it will be e plus 4 and e plus 1. Because e plus 1 is in each side, we can divide it, and large A is going to be equal to e plus 4. And that is equal to ae plus b. So a will be equal to 1, b is going to be equal to 4. So a squared plus b squared is going to be equal to 17. We didn't need to find the exact value of fx.